Hey guys, this is Coach Brian. I am bringing you the 6.1 through 6.9 test review. This entire test is no calculator, and all that you will be provided is what's at the top of this sheet. So you will need to know your unit circle. You will need to be able to create it using degrees and using radians. So honestly, as soon as you get your test, that's the first thing I would do is anywhere you have space, I would go ahead and get that out of your brain and onto paper so that you can refer to it during your test. The resources we have here are the Pythagorean theorem, the 6 trig functions, and the 2 special right triangles. And they've been kind of switched up so that they fit on the unit circle, and they have a radius of 1. Okay. Another thing that might be helpful is go ahead and write your degrees. 60 is a third of 180, so that's pi over 3. 30 is a sixth of 180, so that's pi over 6. 90 is half of 180, so that's pi over 2. And 45 is a fourth of 180, so that's pi over 4. So getting those angles labeled will probably be really helpful. All right, for 1 through 4, for all of these, it's really important that you read all of the directions. So first, we need to find the coterminal angle. It needs to fit into this range between 0 and 360, or 0 and 2 pi. Next thing, we need to identify the quadrant. And then lastly, we need to find its reference angle. So multiple parts here, need to make sure you do all of them. The first 2 are worked for you. The first one is in degrees. The second one's in radians. And this first one, 560 was too large. It didn't fit into the restricted range. So we had to take a turn away, okay? 1 turn. Had to take a turn away so that you could get it into the range. And then you end up with a 200-degree angle, okay? 200-degree angle is coterminal to 560. It's in quadrant 3 because it's a little over 180. And then when you're in quadrant 3, you find the reference by taking standard minus 180. And that's where you get your 20 from. In 2, we have negative 3 pi over 4. That doesn't fall into this range. So what you have to do is you have to add a turn to it. Okay, you have to add a turn so that you can then fall into the range. 5 pi over 4 is a little bit over pi, which is 180. So that again brings you to quadrant 3. And when you're in quadrant 3, you take your standard minus pi, in this case 4 pi over 4, and that leaves you with your reference angle, which is pi over 4. So let's do 3 and 4. For this first one, we have negative 560. This angle is too small. It's too negative to fall into this restricted range. I know that 1 turn isn't going to get me there, so I'm going to go ahead and add 2 turns, okay? I'm going to add 2 turns, 2 positive turns. So that brings me back up to positive 160, and that is in the range that I need to be. And if I were to just quickly sketch this out, if this is 0 and this is 180, 160 puts me kind of in this area. And the reference angle is going to be the quickest way to the x-axis. And so it's going to be that remaining 20 degrees. Also, I'm in quadrant 2. For 4, this angle is over 2 pi, all right? It's over 2 pi, which means I need to take a turn away from it. And remember, 1 turn is 2 pi, but I have to match this denominator. So I can say 2 pi by also using 8 pi over 4. That's still just 1 turn or 1 circle. Once I take away that 8 pi over 4, it leaves me with 5 pi over 4. So that's my coterminal angle. And 5 pi over 4, if this is 0 and this is 4 pi over 4, 5 pi over 4 is going to be down here in quadrant 3. If I'm in quadrant 3, I can find my reference by taking standard, theta standard, minus pi. In this case, it would be this little wedge right here. From 4 to 5 is just a single pi over 4. That's my reference angle. I didn't draw that super accurately because this is a 45 degree. So it should have been more like here. So let me clean that up so it doesn't cause any confusion. All right, so that's what you'll need to be able to do for questions similar to 1 through 4. For 5 through 16, we have, again, multiple directions. Find the reference angle, find the quadrant or axis location. So 5, 9, and 13 are answered. There are examples. So you can see right here for 5, the example gives us pi over 3. Now, a good way to do this is to go ahead and start with 0. Go directly across from it, and using your denominator, put the equivalent of pi. And then go ahead and go up to the halfway point at 90, or pi over 2, and make it equal pi over 2 using the same denominator. So that helps you get really, really accurate. You know that if this is 0 pi, and this is 1.5, 1 will be between them and a little bit closer to 1.5. Also, if you remember that pi over 3 is 60 degrees, you know it's going to be closer to 90. So the thing they tell us to do here, they ask us to find the reference angle and the quadrant. So for this first one, our reference, when you're in Q1, all right, when you're in quadrant 1, reference equals standard. So whatever your angle is, your standard angle is also your reference angle because that's the fastest way back to the x-axis. Let's try 6, 5 pi over 3. I'm going to start over here with 0. This is 3 pi over 3. And you can see I've got 5, so I'm actually going to go back over to the right here, and I'm going to put 6 pi over 3 to represent a full turn. And then between 3 and 6, I have 4.5 pi over 3. So if I've got 5 pi, I'm going to be somewhere over here in Q4, and I'm going to be closer, a little bit closer to 4.5 than 6. So I've got 5 pi over 3. This is in quadrant 4. And my reference, my fastest way back to the axis, the x-axis, is going to be 2 pi minus theta standard. So in this case, 6 pi over 3 minus 5 pi over 3. Excuse me. Excuse me, I'm not re-recording this because I sneezed twice. All right, for 7, we have 7 pi over 6. So this is a little bit over 1 pi. So as I map everything out here, 7 is going to be between 6 and 9, but it's going to be closer to 6. That's in Q3. When you're in Q3, you find the reference angle by taking your standard and subtracting pi. So that would be 7 pi over 6 minus 6 pi over 6, and that leaves me just a single pi over 6, which again represents just this little wedge right here. For 8, we have 11 pi over 6. Hopefully you're at the point where you're starting to recognize that this is really close to 2 pi. It's really, really close to 2 pi. So as you map out your circle here, you can see that 11 is going to be not quite 12, but definitely not 9. It would be about 10, 11 pi over 6. When you're in Q4, which is where we are now, you find your reference. Sorry, let me make that look nicer. By taking 2 pi and subtracting your standard angle. So in this case, we'd have 12 pi over 6 minus 11 pi over 6, and that leaves us with just a single pi over 6 as our reference. Number 9 is 2 pi. You can see it's been worked for us. 2 pi is 360 degrees. 2 pi is 360 degrees. So it's what you get when you make a complete circle. So if I were to graph this, it would look like this. It lies on the positive x-axis. And so if you ask yourself, what's the fastest way to the x-axis, you're already there. So your reference angle is 0. You're already on the x-axis. For pi over 2, if I have 0, pi, halfway there is pi over 2. So you can see that this lies on an axis. We would say that this has a reference angle, not x, positive y-axis because it's vertical. We would say this has a reference angle of pi over 2 because it doesn't matter which way you go. If you go here or here, it's 90 degrees both ways, which is pi over 2. For question 11, we just have pi. So if you started at 0, jumped across to pi, this would look like the following if I were to graph it out. For this, we would say that its reference angle is nothing because it's already on the x-axis, and it actually lies on the negative portion of the x-axis. Lastly, for question 12, we have negative pi over 2. There's two ways you could approach this one. You could go counterclockwise. And so if you started at 0 and over here you had negative pi, down here you'd have negative pi over 2. So that's one option. You could graph it like that. The other option is you could add a term to it. And remember, a term is always 2 pi. So 4 pi over 2. So negative 1 plus 4 would bring you to a positive 3 pi over 2. So you could go this way. Sorry, that's kind of ugly. You could go this way, and that would bring you to 3 pi over 2. These are coterminal, so it doesn't really matter which one you do. You just got to remember that things that are positive go clockwise, or excuse me, things that are negative go clockwise, things that are positive go counterclockwise. All right, 13 has worked for us. 9 pi over 2. If you remember that pi over 2 equals 90 degrees, 9 pi over 2 means you make 1, 2, 3, 4, 5, 6, 7, 8, 9 90-degree turns. And so once this is all said and done, you still end up here with a reference of pi over 2 and lying on the positive y-axis. For pi over 3, if you start at 0 and go over to 3 pi over 3, up here you'd have 1.5 pi over 3. 1 is going to lie right here. If you remember, pi over 3 is 60 degrees, so we're in Q1. Whenever in Q1, reference angle is the standard angle. So we would say the reference is, it is 60 degrees, but we'd say it's pi over 3. Hopefully you're getting a lot faster at these as you go. 7 pi over 6. Again, with more practice, you'll learn that it just lies right over here. If you need to, though, you can still go through this process. But you really will get a lot faster as you learn your angles. This is 7 pi over 6. My reference, since I'm in Q3, my reference is going to be standard minus pi. So pi over 6 is my reference angle. And for 16, we have 11 pi over 6. So again, that's going to be over here in quadrant 4. So we would say that we're in Q4. Our reference is going to be up to 2 pi. So our reference is that last little slice of pi over 6. For 17 through 24, it says find the reference angle and the quadrant or axis for the following angles. So similar stuff. Now I'm going to move a little faster because we are to the point where we should be picking up on these angles a lot faster. So I'm going to go ahead and just for like time's sake, I'm going to go ahead and mark all of these. Here's 60. Here's 120. 240. If this is 180, this is 225. It's going to be down here close to 270. 300. All right. If this is 270. Gosh, I can't write right now. Okay, if this is 270 and this is 360, it's going to be down around this area. 90 is going to be straight up. 135. If this is 90 and this is 180, it's going to split them right down the middle. 180 is just a flat line to the left. And 315 lies right in between 270 and 360. So we've got all of our angles here drawn. The next thing we want to do is put their quadrant. So for our first row here, we've got a quadrant 1, 2, 3, and 4. For question 21, it's quadrantal, so we would say that it lies on the positive y-axis. 22 is in Q2. 23 lies on the negative x-axis. And 315 is in quadrant 4. So next, if you need to look back at your notes, it tells you the kind of formula, if you will, for each of the coterminals. But when you're in quadrant 1, reference equals standard. So our reference angle is 60. When you're in Q2, reference equals 180 minus your standard. So we'd say 180 minus 120 leaves us a reference angle of 60. When you're in Q3, your reference equals standard minus 180. So that'd leave us 240 minus 180. And that gives us a reference angle of 60. And then when you're in Q4, you would say that your reference angle is 360 minus standard. So we would say 360 minus 300, and that gives us a reference angle of 60. So is the reference angle always 60? No. For these 4 examples it is, though. For 21, when you lie on the positive y-axis, you'd say, what's the fastest way back to the x? To go that way or that way? Well, guess what? They're both 90 degrees. No matter which way you go, you have to go 90 degrees back. So you have a reference angle of 90 degrees. Now, we've already done a Q2 one. When you're in Q2, it's 180 minus standard. So we would say 180 minus 135, and that leaves us a reference angle of 45 degrees. When you're already on the x-axis, you don't have anywhere to go to get back to it. So we would say we have a reference of 0. And then when you're in Q4, your reference is going to be 360 minus your standard, which would leave us 45 degrees. I'm going to end here as a part 1 because I'm about to get interrupted by the bell, but I will record a part 2 that covers 25 through 38. So be on the lookout for that after you finish part 1.